Okay, we're going to look at the square root of a complex number. Now, what we'll see in the first example is a very special property. And that is every non-zero complex number has two square roots which sum to 0. So let's have a look at what we're going to do for the first one. We've got to determine the square root of 3 plus 4i. So first step we're going to do is we're going to let z equal the square root of 3 plus 4i, where z is equal to, let's say, x plus I y. So z is some complex number, and we've got to find all of the complex numbers which satisfy this equation. So now we know what z is equal to. We're going to say x plus iy is equal to the square root of 3 plus 4i. So that's just a substitution. Okay, and then we're going to square both sides. Okay, so next step is squaring that side and then squaring that side. So that will result in x squared plus 2i xy, and then it's going to be plus I y all squared, which is equal to 3 plus 4i. Now, I'd expect that you'd be able to expand that perfect square like this. This is what I've expected to see first step. Now, iy squared is I squared y squared, which is going to be minus I squared there, because don't forget that I squared is negative 1. And then I'm just going to put the I there, and then 2x y equals, and then 3 plus 4i. So when you do these questions, I'd expect that you'd be able to go straight to from here to here. Okay, that expansion. Now, we're up to that point, and we've got left-hand side of the equation, right-hand side. What we're going to do now is we're going to equate real and imaginary parts. Okay, so we're going to equate real and, there's meant to be and there, it's not very good and, is it? Stick to doing the word real and imaginary parts. Okay, now that's going to give us two simultaneous equations. Let's see what that looks like. So if you look at the left-hand side of the equation, this is going to be the real part, isn't it? X squared minus y squared, that's going to be a real number. And on the right-hand side, this is the real part, isn't it? Just number 3. So we can say that x squared minus y squared must equal 3. We can call that equation 1. And then if you look at the imaginary part is just the, we can say 2xy must be equal to 4. Okay, so 2xy must be equal to 4. Now, I'm not going to call that equation 2 just yet, because I can do a nice little simplification here. If I divide both sides by 2, I'll get xy equals 2, and I'll call that equation 2. Okay. Now, two simultaneous equations, and we're going to solve those through substitution. Okay, so what we'll do is I'll say, look, from equation 2, I can say, therefore, y is equal to 2 on x, right? And I'm going to sub that into sub into equation 1. Okay, so that'll give us x squared minus y squared, so that'll be 2 on x all squared, and that is equal to 3. Okay, so now we've got a single equation in terms of x. Okay, so let's see what we can do with this. Well, getting rid of those brackets, we're going to get 4 on x squared is equal to 3. And then we're going to multiply through by x squared. So every single term will be multiplied by x squared. Okay, so let's just get rid of that for a minute. Right, so if I multiply every term by x squared, I'm going to get, well, physically, if I did that, if I times everything by x squared, this is essentially what I'm doing. Okay, now that's going to give you x to the 4 minus 4 is equal to 3x squared. Let's change back to a darker blue there. Now, I'll put all the terms on one side, so that's going to give me x to the 4 minus 3x squared minus 4 is equal to 0. Now, you can solve this as a substitution. I'm going to factorize it though, straight away without doing a substitution. So substitution, you could do is let u equal x squared and then do it from that. But let's just write down the equation again, since we're at the top of the page. So we've got x to the 4 minus 3x, hang on, let's go back, x to the 4 minus 3x squared minus 4 equals 0. Okay, so x to the 4 minus 3x squared minus 4 is equal to 0. Right, so if we just factorize that like we would a normal quadratic, this is a quartic equation which can be reduced to a quadratic. So if I put x squared there, and x squared there, 4 there, 1 there, negative there, positive there. Now, what have we got here? We've got two equations. So we're going to have x squared plus 1 equals 0, and x squared minus 4 equals 0. Now, if we work this part through, we get x squared, should I just save a bit of room here? So you're going to get x squared equals minus 1, so x equals plus or minus I. And then over here you're going to get x squared equals 4, so x equals plus or minus 2. Now, I'm going to tell you that the left-hand side working out is not necessary because we know that x is real, don't we? X is an element of the real numbers, right? Which means x cannot be plus or minus I, it has to be plus or minus 2. It's actual fact, when you do these questions, you're not going to do this bit, right? You're not going to do that bit, and you're not going to do that bit, right? Because you know that x is real, so you're just going to jump straight to the real equation. So you're not going to do that bit either, okay? So you're just going to do the x squared minus 4 equals 0 because you know that gives you a real answer. All right, so x equals plus or minus 2. Now we've got the possibilities. What do we have? We're going to sub those numbers, right? Let's use pink for this one. So if you look at, scroll down a little bit, this guy down here, we've already done the work. so might as well use it. So this equation down here is what we're going to use because we know that y is 2 on x. So just from here, if x is equal to 2, right, sub into that equation, then you're going to get y is equal to 1. And then if x is equal to negative 2, y will equal to negative 1. All right, so we've got our x and y values. That means when I go back to my answer, we know that z is what we're trying to find. Z is equal to x plus iy or yi. So that means z is equal to 2 plus 1i, which is just I. And the other one is z is equal to minus 2 minus I. So those are your two answers. Now, we did say that these could sum to 0, didn't we? So if I went 2 plus I and then added minus 2 minus I, you get 0, wouldn't you? So we've proved the opening statement there. The opening statement said every non-zero complex number has 2 square roots which sum to 0, which is not really a proof. We've proved it for this particular question, okay? But it is true for all other non-zero complex numbers, okay? So if you add those two answers together, you're going to get 0, okay? So I could say, what's my final answer? And actually, I'm just going to do something else here. Do you notice that this is 2 plus I, and I could take it a negative here as a common factor and get 2 plus I. So that means I could say Z is equal to plus or minus 2 plus I. So I could write and you need the brackets there. That's the neatest way to write the answer. All right, so in conclusion, what would I write down is the square root of 3 plus 4i. Okay, 3 plus 4i is equal to plus or minus 2 plus I. Okay, so that's my final answer. Right, so started off with square root of 3 plus 4i, and that's what we've ended up with. Now, I just want to point out also there is an alternative way to solving those simultaneous equations. Okay, so, and it's called solving by inspection. So this one here is the algebraic solution. I just want to take you to just something which is a little bit easier. Now, this method is not always going to work, and I think we might have run out of room here. But have a look at the two equations, x squared minus y squared equals 3. So x squared minus y squared equals 3. And the other one was x, y is equal to 2. Now it's called by inspection because if you look at the second equation, you need two numbers which multiply together to give 2, and then two numbers which, when you square them and subtract, you get 3. So without doing too much brain power work, you can work out that the two numbers are going to be 2 and 1, okay? Because 2 times 1 is 2, and then 2 squared minus 1 squared is 3. Now, once you've chosen the numbers, you just have to choose the correct order. So obviously, you're not going to put x equal to 1, because then you'd have 1 squared minus 2 squared is negative 3, which is not what you have here. So x is equal to 2, and y is equal to 1. Now, that's only going to give you one of the answers. Now, because you've got x, y equals 2, you can also choose negative numbers. So up here, you've got 2 and 1 as one answer, but obviously the other answer will be the negative of that. So you could then also write that x equals negative 2 and y equals negative 1. And when you sub that back in there, negative 2 times negative 1 is positive 2. Negative 2 squared, take negative 1 squared is 3. So with some of these questions, this algebra that we did, the substitution method, you can work out the answers by solving by inspection. Okay, so that method there is, and it's basically just trying to, if you like, guess the numbers. So solve by inspection. Okay, so in other words, you could go straight from, once you get your equations, here they are. So equation 1, equation 2, you could go straight to here. Here we go. So let's see the pink part there. Oh, where's my little pen gone? All right. Here we go. So straight from these equations to your answers. You can bypass all that algebra. Okay. So have a go at question 2. You can pause the video if you like, and then see how you go with question 2. Same steps. All right. So let's have a look for question 2. We're going to let z equal x plus iy, or a plus ib. So then you're going to get by substitution. Now, by the way, when you do that, technically you just say x and y are real numbers. Okay. So you're going to get x plus iy all squared is equal to 5 plus 12i. Now, expanding the brackets, you're going to get x squared minus y squared plus I 2xy is equal to 5 plus 12i. Now we're going to equate the real and imaginary parts. X squared minus y squared equals 5. So that's our first equation. And then we've got 2xy is equal to 12. Oh, by the way, that's equation 1. And then that's going to give you xy is equal to 6. We'll call that equation 2. Now, we could solve this by inspection. So if I was going to solve this by inspection, I'd have to think of 2 numbers which multiply to give me 6. But the difference is when I square those numbers and find the difference, I get 5. So just by inspection, by inspection, you're going to get x is equal to 5. Sorry, not 5. Yeah, sorry, that's not right, is it? X is equal to 6. Y is equal to 1. That's not going to work either, is it? It's going to be 2 and 3. Yep. So x is equal to 2. Now, we want the difference to be 5, so I'm going to make that the bigger number. X equals 3 and y equals 2. Okay. So 3 2s are 6, and then check it. 3 squared minus 2 squared gives you 5. All right. Now, we can also do x equals negative 3, y equals negative 2. All right. So then we've got our answers that we need. And that means z is equal to, it's going to be 3 plus 2i, and we're going to put brackets around that, and we're going to make plus or minus, okay, because that combines both those answers. So that's the quickest way to do it. Let's just say you did want to solve it algebraically just for practice. Well, for practice, you would go from equation 2. So from equation 2, you have y is equal to 6 on x. Then you're going to sub that into 1. 1 is x squared minus y squared equals 5. So sub into equation 1. So that would be x squared minus y squared. Now y squared will be 36 on x squared equals 5. Then I'm going to multiply through by x squared to get rid of the fraction component, because we want to get rid of that fraction component there. That's the whole purpose of multiplying through by x squared. That's going to give you x to the 4 minus 36 equals 5x squared. Okay, then you're going to put everything to one side. Okay, so you've got to factorize that. So let's do that. X to the 4. So come up here now. X to the 4 minus 5x squared minus 36 equals 0. Okay, so from that, we've got to factorize this like a quadratic. Okay, so x squared there, x squared there. I want to have a 9 here and a 4 there. Okay, and then minus there and then plus there. Now, I'm going to choose just the one which gives me real solutions only. Okay, so I'm just going to go x squared minus 9 is equal to 0. So it gives me x equals plus or minus 3. All right, and then I'm going to get the same answers because I'm just going to substitute into x. So we know xy equals 6, for example. So I'm just going to sub into y equals 6 on x. So that's going to give you x is 3, and that means y is 2, and then x is negative 3, y is negative 2, and then put in your answer. Z will be plus or minus 3 plus 2i. So that's your answer. All right, now last question, number 3. We can apply this idea of the square root of a complex number to a quadratic with complex coefficients. So if you look at the coefficients here, they're complex numbers, aren't they? So let's just apply the quadratic formula. So x is equal to minus b, so minus 1 minus I, plus or minus the square root of b squared, which is 1 minus I all squared, minus 4 times 2 times 1 minus I, all over, it's a bit of a monster, 4. Okay, now that's going to give me x equals minus 1 minus I plus or minus the square root. Now, if I expand these brackets, I'm going to get 1 minus 2i, and then I'm going to square I, so it's going to give me negative 1. And then I'm going to have minus 8 times 1 minus I, so that's going to be minus 8, and then minus 8 times by negative I is positive 8i. Okay, all over 4. Okay, so that is going to tidy up a little bit to this. Square root. Now obviously the 1 minus 1 goes. So 1 minus 1, see you later. And then we've got minus 2i plus 8i, which is 6i and negative 8. So we've got negative 8 plus 6i inside the square root. Okay. And then that's all over 4. There we go. All right. So what we're going to do next is find the square root. So we want to find the square root of negative 8 plus 6i. So let's just diverge just to focus on the square root part. So we're going to say, well, let z equal the square root of negative 8 plus 6i. Okay. So that's going to give me x plus iy, I guess. Yep. So x plus iy, or a plus ib in this case. Let's do a plus ib. That'll be a better letters to use because we've already got x. So let's just say this is a plus bi is equal to the square root of negative 8 plus 6i. Now, we're going to square both sides. So let's do that. So squaring both sides. And we get a squared minus b squared plus I times 2ab is equal to negative 8 plus 6i. Okay, so let's equate the real imaginary parts. Okay, so equate real and imaginary parts. Just abbreviate that. So it's going to give you a squared minus b squared. Let's get rid of this. A squared minus b squared is equal to negative 8. Okay, so equal to negative 8. And the other one, of course, is 2ab will equal to positive 6. So let's write that down. Now, that's equation 1, and AB equals 3 is equation 2. Now, let's solve this by inspection just to take a bit of a shortcut. So I need two numbers, A and B, which multiply to give 3. And when I square them and find the difference, I get negative 8. Now, obviously, the numbers are 1 and 3. Now, which one's 1, which one's 3? Well, A will have to be 1 because I want to get a negative number up here. So I'm going to choose A is 1 and B is equal to 3. Okay. Now, the other option, of course, is negative 1. A equals negative 1, B equals negative 3. So then I can say that Z, right, Z is equal to plus or minus 1 plus 3i, and make sure you have the brackets in there. Okay. All right. So we've got our answer. So we now go back to the quadratic equation up here, and okay. So let's just write that down again. So a quadratic equation. Let's just go back to a different color here. Here we go. All right. So our quadratic equation was x equals. Now we've got the minus 1 minus I there. Minus 1 minus I. Right. So you go back up here. There it is. And now we've got the square root of negative 8 plus 6i. So it's going to be plus or minus, which we already found. So where's my pen gone? There we go. So plus or minus 1 plus 3i all over 4. Okay, so all I've done is I've replaced, I'll just do this in a different color. I've replaced the square root part here, right, with 1 plus 3i. Okay, and we've already got the plus and minus already. Okay, so now all you've got to do next is simplify that last answer. So if I draw a little dividing line here, let's simplify that. So you've got x equals, now if I expand the first bracket, I'm going to have I minus 1 or minus 1 plus I, right, plus 1 plus 3i on 4. Okay, that's one of our answers. So it's going to give me minus 1 plus 1, which is 0, and I plus 3i, which is 4i, all divided by 4, which is just equal to I. So that's one of my answers. The other answer, right, I'm going to have to use the minus sign here. So x is equal to, I've got the minus 1 plus I there, but obviously I've got to take the negative to include the other case. Okay, because it's plus or minus 1 plus 3i, all divided by 4. Now, I'm not going to get a cancellation here. I'm going to get minus 2 there instead. And then I minus 3i is minus 2i. That's all divided by 4. And then that's going to give you minus a half minus a half I. Okay, so that's the answer. All right. So now there is one thing we should mention. So I'm just going to add an extra page here. So let's just put an extra page here. Page, insert, do a blank page, and I want to move that down. So let's move that page down. There you go. All right, so one thing we should point out is that when you're solving a quadratic with complex coefficients, the answers are not necessarily complex conjugates, are they? Okay, so let's write that down. So key points. Key points. Number one, when solving quadratic equations, with complex coefficients, right? Now the answers are not necessarily I'd say, so when solving, so actually rather than saying complex coefficients, let's just say, just to be a bit more specific, non-real. Okay, when solving quadratic equations with non-real coefficients, the roots of the equation, roots of need not be complex conjugates. Okay, so now that brings up another point. What if the coefficients of your quadratic are real? That means your roots may be complex conjugates. Okay, or they will be complex conjugates. But if they're non-real, they need not be. All right, so that's it for the lesson.